So, if I want to solve this, this is a pretty simple inequality to solve. I'm just going to subtract that 1. 2x is greater than or equal to negative 1. X has to be greater than or equal to negative 1/2. So when I'm looking at answers for this, the answers have to be greater than or equal to negative 1/2. If I plug in negative 5, it gives me a negative and a square root, which is not going to be a real answer. So I'm going to hold on to this, and I'm going to solve my inequality now. So over here, if I want to solve this inequality, these are going to not be the super crazy complicated ones. They're going to be more like the ones from Friday night where you just solve more simply. So you could add that 7. So you would get the square root of 2x plus 1 is less than 11. Then we would need to square both sides. So we would get 2x plus 1 is less than 121. Now we need to subtract that 1. So 2x is less than 120. Divide by 2. X is less than 60. Now, here's what's going to be different for these problems. I have to consider the domain as well. So, for this problem, if I think about the number line, right, I'd have 0 right here. 60 would be way up here. Negative 1/2 would be way down here. So, if I just left my answer as x is less than 60, that would include all the numbers here, but it would also include numbers like negative 5. And negative 10, and negative 1,000, right? And if I plug numbers down here in, it's going to give me something that's undefined, or imaginary, because I got negatives under the square root. So what I've got to think about here is I got to think about all of the numbers that satisfy both x is less than 60 and x is greater than or equal to negative 1/2. So less than 60 would be all the numbers below 60. But greater than or equal to 1/2 would be closed dot, everything above this. What we're looking for is the part where they overlap here. So they overlap. We've got a closed circle right here. They overlap in between. We got an open circle right here. And so if I want to tell this section, I would say negative 1/2 is less than or equal to x less than 60. Typically, I'm not sure exactly why, but typically you're going to see this use inequality notation instead of interval notation. There's a chance they could use interval notation. It'd be negative 1/2 to 60 if they did. But I think you're probably going to see inequality notation more often for these problems. Intervals used a lot more for like domain and range for equations.
Can you explain again, like open and closed circle?
We're going to use open circle if we have a less than or a greater than sign. So less than or greater than, that's going to be an open circle. If we have less than or equal to or greater than or equal to, that's going to be the closed circle. So as long as your x is first, if we're looking at numbers less than 60, those are the numbers below 60. A lot of times I tell students to look. It looks like the arrow is pointing to the left. For this one, looks like the arrow is pointing to the right. Just be careful because the x has to be first if you're thinking that way.
Is your domain always going to like go before the x? So like, is it always going to be domain x then like you get for the x?
Not necessarily, but usually. Okay, so usually, but not always. And there'll be some times, we're going to see here in a minute, where we don't even use our domain. And I'll show you what that's going to look like, because it doesn't even matter for what we're doing. So you really just want to kind of look at what you've got, put it on the number line, see where it falls. Make sure when you're writing it this way, always use less, put your lowest number first. Always use less than signs when you're writing it this way. So if you're writing between two numbers, put your lowest number first, less than x, less than the highest number. And then you'll decide whether it's or equal to based on whether or not it's closed circle or not. So we'll write it, typically, domain's going to be on the left-hand side there, but not always. Okay, questions? All right, let's try another one. Let's do 3 square root of x minus 5 is greater than or equal to 36. Okay, so for this problem, once again, we always want to think about our domain first. Because I always do it, I mean, technically you could think about it at the end, but I always do it first because sometimes you'll forget about it if you don't do it first. So x minus 5 has to be greater than or equal to 0. You just take whatever's under the square root, it has to be greater than or equal to 0. So x has to be greater than or equal to 5. We're just going to hold on to that because that's a restriction on the type of answers that we can get. Alright, so to solve this one, what should I do with this 3? Let's divide it off first so we don't have to deal with it. So square root of x minus 5 is going to be greater than or equal to 12. We're going to square both sides, so x minus 5 is greater than or equal to 144. And then we'll add our 5. And x is greater than or equal to 149. So, we got to look only at places where both of these are true. So, on our number line, 5 would be way down here. And 149 would be way up here. So, if I'm thinking about x is greater than or equal to 5, that's numbers that are greater than or equal to 5. It would look like this. Right, so I'd use a closed circle. I would shade to the right. Those are all the numbers bigger than 5, right, and including 5. For x is greater than or equal to 149, I would also need to use a closed circle. Which direction do I need to shade? To the right, also on this one. So this time, we're always only looking where they overlap. Okay? Do they overlap between 5 and 149 this time? No. So the answer is just 149 and above, which is just x is greater than or equal to 149. So in this case, we don't use our domain at all. And the reason is because we had a greater than sign here, we were talking about numbers that were bigger than 149. That was our answer. So any number bigger than 149 is also bigger than 5. So we don't even have to worry about the domain here. This happens more often when you have a greater than sign rather than a less than sign, although I guess it could happen with a less than sign if you had the right kind of numbers here.
Because usually when you solve the equation, the number that you get is going to be more than your domain.
Right. So typically if you have a greater than sign, this is usually bigger than your domain, meaning that your answers are going to fall in where it's already in that category. And, I mean, you don't necessarily have to draw the graph. I just kind of like to draw the graph to, like, help you picture. But if you get, oh, greater than or equal to 149, that's already bigger than 5. I don't have to worry about it. Just circle this. That's fine. Also, you don't necessarily have to show the graph. That's just sort of a tool to help us keep that straight. Okay, questions? another one. For example 3, let's do the fourth root of 2x plus 3 is less than or equal to 3. If I have a fourth root problem, I still have to check my domain, because with any even numbered root, whatever is underneath the root has to be greater than or equal to 0. So I still have to do 2x plus 3 is greater than or equal to 0 here. So 2x is greater than or equal to negative 3. Divide by your 2. X is greater than or equal to negative 3 halves. So that's our domain. It may or may not end up affecting our answer. I think it's more likely for it to affect our answer since I got this less than sign here. So, questions so far? Alright, how do we undo a fourth root? We go to the fourth power. So instead of squaring both sides, we're going to raise both sides to the fourth power, which will just get rid of our fourth root on the left-hand side. We got to do 3 to the fourth here. What is it? It is 81. And so we're going to subtract our 3. 2x is less than or equal to 78. Divide by 2. X is less than or equal to 39, I believe. So our answer is numbers that are less than 39, less than or equal to 39, but we've got to consider our domain, right? So the domain says that numbers have to be greater than or equal to negative 3 halves. The answer says that numbers have to be less than or equal to 39. So these are going to overlap in between those two numbers. So we're looking right here. I've marked that in red. So, Major, how am I going to write that answer?
Would it be negative 3 halves is less than or equal to x, and then less than or equal to 30.
Perfect. That was great. Okay, questions? Yes. You can. Usually we're not going to see it written that way with these. They just, for these type of problems, typically don't write the answers like that. But if you did, it would be negative 3 halves, 39, and you'd use brackets for both of them. I kind of like interval notation better and think it's a little easier, but you're probably not going to see it on this. I'm not really sure why they don't use it much for this, but they don't. Alright, I got one more I want us to look at. I think that'll do all we need to do here. So, for example 4, let's do one that looks like this. Square root of m plus 8 is less than or equal to the square root of 2m minus 6. So this time we've got square roots on both sides. So we actually are going to have two domains we've got to consider. We got to think about m plus 8 being greater than or equal to 0. So that means m is greater than or equal to negative 8. Use red for, use purple for this one. And we also have to consider 2m minus 6 has to be greater than or equal to 0. So that'd be 2m is greater than or equal to 6. Divide by your 2, you'll get m is greater than or equal to 3. Now let's think about this for a second. If I've got m is greater than or equal to negative 8 and m is greater than or equal to negative 3, do I need both of those? If a number is bigger than 3, is it also bigger than negative 8? So I could just think about this one right here because that's the larger number that we're dealing with in this case. Or you can graph all of them. It doesn't matter, but it's unnecessary to use that m is greater than or equal to negative 8 because if a number is bigger than 3, it's also going to be bigger than negative 8. All right, so we're going to solve, square both sides. So m plus 8 is less than or equal to 2m minus 6. Here, it's up to you on whether or how you want to move these m's, but one of them's got to go. I'm going to subtract my m right here. So 8 is less than or equal to m minus 6. I got to add that 6. So 14 is less than or equal to m. And so I'm going to write this back around this way. M is greater than or equal to 14. If you move the m to the other side, you got a negative 1. What have you got to do if you have to divide by a negative number? Flip the sign. So you might want to put yourself a note over there. It's not going to happen a lot on these problems, but it may sometimes if you divide or multiply by a negative, flip the sign. Okay, so if we think about our answer here, and you don't necessarily have to graph it, but I'm going to even put my negative 8 here. I got my 3, and then I've got my 14. So my negative 8 numbers have to be greater than or equal to negative 8. For my 3, they also have to be greater than or equal to 3. But my answer is greater than or equal to 14. So you're looking for where all 3 of these overlap, which is really just greater than or equal to 14. So we could just say that as our answer here. Because if a number is bigger than 14, it's also bigger than negative 8 and positive 3. So we don't have to worry about the domain on this one. Questions? Okay, so I think you should be able to get done